Sorry about that quick pause. So as I was saying, this limit as x goes to 3 being 7, and then the value f of 3 equals 7, there's really no connection here. One doesn't rely on the other. Oops. Like one has no bearing on the other. Okay, let's try another problem. Alright, so this time I want to evaluate the limit as x goes to 3 of 2x squared minus 5x minus 3 over x minus 3. So the equation that we're talking about is 2x squared minus 5x minus 3 all over x minus 3. Variable that we're looking at is x. The number of interest is 3 again. Now the limit. So looking over here, so this is our number of interest, and as I choose x values from the left that get close to 3, the y value again appears to be going towards 7. And then if I try it again on the right, if I choose y values on the right going towards 3, x values, the y values do appear to be going towards 7 again. So my guess is that the limit is 7. So I think the limit is 7. If I look at it from the left, so again, I'm just going to draw like a line here at 3. So this is the left side, this is the right side. I'm supposed to do the limit from the left, so I'm going to ignore the right side completely. And as I look at this line right here, the line is getting closer and closer to a height of 7 right there. So then I want to do the same question from the right as x goes to 3 from the right. Same thing, but from the right. So I'll erase what's here. So I'll just draw this little line at 3. And now I'm ignoring everything on the left. And then I think about what height this line is going towards as I get closer to 3. And that is still 7. So are they the same? Yes. Which means the answer to the question is the limit does exist, and the answer is 7. But what's interesting and what we've kind of talked about is that, oops, my bad, use the eraser, is that g of 3, in this case, when I come up here, g of 3, that doesn't exist, there's nothing there. But that still doesn't matter about the limit at all. What's actually happening at 3 doesn't matter. It's just what's happening near it. Okay, let's do another one. I think this is the last one. Evaluate the limit as x goes to 3 of 1 over x minus 3 using the table and or the graph. So either way. The equation is 1 over x minus 3. The variable is x. The number of interest is 3. But this is a little bit confusing in two places. So as I take x values that get closer and closer to 3 from the left, the y values, they don't get closer and closer to something specific. They actually seem to be getting more and more negative. And if I choose x values from the right and get closer to 3, the y values get larger and larger and larger. So these are opposites. So looking over here, as I go from the left, the value is negative. And from the right, the value is positive. So they don't match up in any way, which tells me that the limit does not exist. So from the left, this value, actually let's erase that. If I take the limit from the left, that's becoming closer and closer and closer to negative infinity. It's like a straight line down. So I'll say negative infinity. And then from the right, it's getting bigger and bigger and bigger, so I'll say positive infinity. They are not the same. So the limit does not exist. Now if I try to plug in h of 3, there's nothing there. That's this line right here. So h of 3 also does not exist. Yeah, so this limit does not exist because the limits from the left and the limits from the right don't match up. So let's pause right there and we'll come back to it later.